All right, so we are covering the daemon thread right now. And regarding the daemon thread, we had the conversations, right? That when we create a game, there we have taken the example of Mario, right? So in the Mario, the main player or the protagonist is the Mario player, and but there are multiple factors that exist in the game, like the enemies or the background clouds that happens, right? So these two things, these keep on running, right? Okay, should I open the Mario game again? All right, see this. Okay, just give me 1 minute. All right. Hi everyone. So we were at the Mario game. All right, so I'm audible. Hello.
Yeah.
All right, so this is the Mario game, right? So one is the player that I'm playing with, right? So this is the player that I'm using. And this thing, now I'm back. See, when I'm moving, try to look over here, right? Clouds. Right now this game is not much, I mean, very engage engageful when it comes to the background. But the thing is, as soon as I move, right, the crowd will also, the background will change, right? It's not just about the cloud, and these players are also moving, right? Visible? These owls are moving, right? I mean, before I killed them, but they are moving, right? And the background is also changing, right? I'm audible.
Yeah. Yeah.
So these are threads, right? So the background in the, see, this is running on a thread, right? And I am also a thread, right? I mean, I don't know how Mario, oh shit. All right, cool. Let it run again. Okay, cool. I'm at the start. So see, the thing is, this is a thread, the owl, and the background is also a thread, right? We are clear till now, right? We had conversation regarding the course and how the course is implemented, right? And the peak processing power. I'm audible.
Yes. Yes.
All right. So
Yes.
see what happens. This is a thread, right? This is also executed by a thread. This owl is also executed by a thread, right? So when can we decide the game should stop? Because this is the owl coming, will keep on coming, right? Because it is executed by a thread. And right now the game's background is static, but if it's something else like NFS or something, some good game, then the background will keep on changing, right? In the NFS there will be police cars, or some other cars will pass by, or there will be wind, right? Trees falling. Similar in the GT as well. So what should be the condition for game to end? And there are multiple threads, right? This is the thread that I'm using. Let's call it the main thread. And then one thread which keeps track of the background, one thread which keeps track of the, oh shit, players, I mean, that we have, I mean, the enemies like the owls or the ducks in the game, right? So what should be our criteria to end the game, to end the threads? The criteria should be, if the main threads or the players are dead, right, then I should stop the game, right? If my main player is dead, or I mean something happens, or then these threads of the background and all these characters, it should stop, right?
Yes. Yeah.
So that should be the case, right? So if I try to do suicide over here, not in literal case, if I go down, then the game's end, right? Does not matter whether this owl keeps on moving or coming, right? It will stop, right? That's what happened, right? The game is on continuous loop. If I stop, then game would have ended, right? So this is the main thread, right? This is the main thread, and the non-mandatory thread or the background thread, this is the background, right? This is the background task that's happening, and the owl moving is also a background task, right? So it's the non-primary threads or the background threads is called daemon threads, right? So the owl moving is a daemon thread, it's not required. Me moving is a daemon thread. So if the daemon thread is keeps on, is if daemon thread exists, then our system should not end, right? Our JVM should keep on executing. That should be the case, right? The game should not end until my main player is existing. Okay, I'm way too involved in the game. Let's end it. All right. So is this thing clear? Regarding the main
Yes.
thread and the daemon threads, right? Daemon threads are the background threads. Do we know anything that happens in the background when we run the Java? Something with collector. Okay, let's cover first this thing. Until the main thread or non-daemon thread, right? Because the daemon thread is the thread which is the background, right? The helper threads. And if we don't care whether the helper threads exist or ends, right? But if our non-daemon thread, which is also we can call it the main thread, why we don't call it the main thread? Because we already have the main thread, and there is already enough confusion of the main thread group, the main method and the main thread, that we don't call it main thread. So the thing is, there are background threads and non-background threads. All right. So we don't care whether the background threads is running or not, right? Because background threads are basically helper threads, right? The owl moving of the owls, or the background changing of the background from day to night, or movement of the clouds, right? It's a temporary thing or it's a background thing, right? But the movement of the main thread is something that we need to take care, and we should not end the game until the main player exists. If the main player is dead, or the protagonist is dead, or the player is dead that we are playing with, then it does not matter whether the daemon thread exists or not, right? We will kill those daemon threads, right? Like of the background and the owl. I'm audible?
Yeah, yeah.
Okay,
Got
so
it.
see, the daemon thread in Java that runs in the background is garbage collector. We don't see it, right? We don't run it, but it keeps on working in the background. But as soon as our method ends, that this method ends, right? We don't care whether the garbage collector is running or not, right? We just kill that thing. We just shut down the JVM completely. So the daemon thread is the background threads, and we don't wait for their execution. And we will see the example. And the non-daemon thread, we wait for the non-daemon thread execution. Let's see an example. So over here, main thread ends. Cool. Main thread ends. So over here, let me write a thread. So thread equals to new thread, and then what we can do is not like this, but over here what we can do is provide the implementation. All right. So over here now, while what we can, while true. Okay, okay, I'm setting the example of daemon thread, right? So I'm making a loop, infinite loop, and let's print something non daemon thread running, so JVM will not shut down. All right, and then let's wait for thread.sleep of 2 seconds. All right, so what will happen now, that we have created a thread by using the lambda, and over here what I'm going to do, for infinite time I will wait for 2 seconds. Okay. Oh shit, inside lambda we need to, all right, cool. This thing can work outside the lambdas. Inside lambda we need to use the try catch. We have no alternative choice. Cool, no worries. Okay, so okay, this is the okay, but if I convert into task, then also it will happen. Cool, no worries. So we need to have this try catch here. So now if we run, what will happen? For eternity, the non daemon thread running will be printed, right? And after 2 seconds. So if I run this thread, JVM will not end, right? Main thread. Okay, I haven't started the thread. Okay, cool, no worries. Okay, so let me start the thread. Thread.start. Cool. Now if I run it, main. Okay, yes. See, it's up and working, right? After every 2 seconds. Okay, I think is it taking 2 seconds. All right. So in every 2 seconds, what will happen? It will keep on printing, right? The reason is it's non-daemon thread. It's not a background thread that's running. So the main thread or the non-daemon thread is running. So that's why JVM will never going to be shut down. It's like we are the main player or the main protagonist is exist. So the background also will keep on working and our game will not end. But the same example. But for the same, okay, let's do one more thing. Let's wait for the okay main thread. Let's wait for 2 seconds. Let's wait for 10 seconds, right? Let's wait for 10 seconds and then our main thread will end, right? Let's run it. I have restarted it. So thread, okay, see multiple times this will print. Then after waiting for 10 seconds, main thread will end, right? Main thread ends. Still our non-daemon thread is running, right? And the JVM is not shut down, right? It's still active. That's why we are seeing this thing printing again and again. But if I make this thread, I'll make this thread as daemon thread. All right, now I have made this thread into the background thread. That means I have mentioned to the JVM that all right, if all the non-daemon threads ends, then this don't wait for this thread and shut down the JVM. That means let's suppose in that game that we have seen the Mario, we had owls, turtles, right? Owls in the clouds, and I want to add the turtles as well. So let's say I have created this thread as a turtle in the games, right? Let me change it to the turtle in Mario, right? So I have added turtle in the Mario, but I want it to be as the non-daemon thread. I don't care whether the turtle is alive, dead. If the Mario is dead, don't care about this turtle to be alive. Kill that all the turtles as well. No need. So I have made sure that the turtle in the Mario is the background task that's happening. It's not the main thread or the main task that needs to be executed. Clear? I'm audible?
Yes.
So what will happen if I run this? Okay, see, this thing is still running. Keeps on running, right? It's not ended. If we'll see. So now I have to close it because it will run it after eternity. What will happen if I run this code now? See what I have said. That means if the main thread ends, it will not wait for the background thread. Alright, so that means as soon as the main thread ends, because there is 2 threads, right? In this code, there is only 2 threads, right? I'm audible? Which are the 2 threads in the code that we are seeing right now?
Main and turtle in Mario.
Alright, we haven't, it would be thread 0, thread hyphen 0, but no worries. Yeah. So these are the 2 threads, right? And which one is daemon and which one is non-daemon?
Turtle in Mario is the demon, right?
Yes, and the main thread is non-daemon, right? We haven't changed it. By default, it's non-daemon. So it will wait. The JVM will run till all the non-daemon thread exist. As soon as all daemon threads are dead, it is not going to wait for non-daemon threads. That's why they are background threads, right? So that means as soon as the main thread, we have only 2 threads, right? Main is the daemon thread, non-daemon thread, and turtle in Mario is the daemon thread. So as soon as my main thread ends, it will not wait for the daemon thread. And even though I have written over here while true, it is not going to run for infinite. All right, that should be the case, right? Whatever I had told till now. Is it clear? All right, let's try to run it and then see. If we run it now, the main thread is the non-daemon thread. So all right, okay, now it's the daemon thread, right? It's okay. Wait, let me close it. Let me change this thing also. See, this is the daemon thread, right? So background, and let me write here the background TRO20 thread. All right, so let's run it. All right, so the main thread is the non-daemon thread, right? And then the daemon thread is running, and as soon as my main thread ends, see over here, JVM also ends, right? Visible? Okay, is it clear or not?
Yeah.
Clear, right? If we just remove this line, then it will execute infinitely, right? Because this will also become a non-daemon thread. So that's the difference between daemon and non-daemon. If someone asks, you can provide this example and everything will work great, right? If you can write examples, then the person will think that all right, the person has the knowledge, right? All right, cool. So this was the and that question. Okay, all right. So what will be the, see, I have set, all right, if the non-daemon thread, this is the non-daemon thread, right? This is the non-daemon thread. So one thing is there also, if the non-daemon thread, it's a, sorry, daemon thread, if the daemon thread creates a thread, so will it be a thread, okay, thread and child thread of daemon. All right, and then new thread and just simple empty we can keep, no issues, child thread of daemon thread. Cool. So will the child thread of daemon will be a daemon by default, or it will be is daemon, or will it be non-daemon? All right, anyone wants to answer? Okay, let's just run it and see. Child thread of a daemon and is daemon, and the answer is, hello, I'm audible?
Yes.
So the main thread, is main thread a daemon? No, right? And see, this thing makes sense also, right? If a non-daemon thread creates a thread, right, so it will be a part of that daemon thread, right? If a background thread creates a new thread, then that thread should also be considered as the background thread only, right? Because if we have a thread that takes care of the background, in the background there can be multiple threads, right? There can be, okay, for example in the Mario, okay, not in the Mario but in some other game, the background can consist of a cloud that is moving, birds, right, and the sun, right? There are three, so the main thread of the background needs three more threads, and these three threads are uh, sun or moon, then birds, and then clouds. So if the background is a, oh sorry, if the background image of the game is a is a daemon thread, that is background thread, then all these birds, clouds, and sun or moon should also be non-daemon, right? Sorry, daemon, right? That should also be considered as a part of background only, right?
Yeah.
All right. So that's why the daemon thread, if a daemon thread creates a daemon thread, and non-daemon thread creates a non-daemon thread. So that's what's happened with the threads, and same goes with the priority as well. If we inherit the priority from the parent, and we inherit whether we are the daemon thread or not, we also inherit from the parent. So if I made this thing daemon, then whatever thread turtle in Mario or the background in Mario, if I try to create anything, if it's not the background in the Mario, it's the background in Mario and the child thread is the turtle in the Mario, then the turtle, moon, cloud, everything will be a daemon thread, right? So these are the only two questions that usually asked in with the daemon thread. All right, let's now move. Okay, now move to different thing. Right now we have multiple thing already left, so we are going to cover the thread executors first. Okay, okay, we are not okay, we haven't even covered the callables, right? Okay, okay, I don't think we have covered the callables. Cool, no worries, we'll cover the latch barrier between the executors. So we will cover the executors, we will cover this thing callable also in the with executors also. See, in the very first part of the session, I have mentioned it. Okay, we are not doing thread equals to new thread, or we are not doing or even the thread dot start we are not doing, right, in today's scenario. So in executors, okay, so let's create the basics. Okay, no interview question will be okay, but there is no interview question from here. Interview questions, but one interview question is there. All right, we'll cover that then. All right, so the very first thing, basic thread executor runner, and instead of this we can call it all right, thread executor is good enough, and psvm. So earlier if I want to run something, I was doing runnable. Oh my bad. So runnable and task. Let's suppose we have a task to print uh, 10, right? Print count digits task, right? So or simply okay, greeting task, and simply what I want to do with my thread is greet the user. Hello user, happy new year. Okay, happy new year everyone. So happy new year, this is the example. So this is the task that I want to execute, right? Greet happy new year, greet happy new year. Cool. So earlier what I was doing, I was creating a thread greeting thread equals to new thread, and then I was adding task to my thread, and then I was running my thread, right? And this is the thing that we were doing, right? I'm audible?
Yeah, yeah.
So what's wrong with this? First thing, I mean, and what's the drawback of this? Another thing, if I want to greet multiple people, like for example, okay, my bad. I want to greet multiple people. Let's suppose users and and right. So we have these users, right? So what I'm going to do, I'm going to write a loop, and okay, if some part of it you are unable to understand, no worries, we are going to cover it in later part, but it's basic. If you are able to understand this, and we're good, otherwise it's way too basic, right? Everyone can understand, I am at least hoping. So what I can do, okay, but the task is just a simple task and I'm not looping it over. Okay, all right. So instead of ln, No, okay, I can write ln. All right, cool. So what I can do, I can just remove this thing from here and put the name first, but it won't make sense. Okay, but then I have to create multiple tasks. Okay, okay. So what I can do is simply put all this thing into, okay now, but if my task is okay, so one thread will be used. I need something that requires multiple thread. Okay, okay. Cool. So how can I make sure over here multiple threads will be there so it won't make sense? All right, so we cannot use this example. All right, see, okay, we could have created everyone, but no worries. Over here, if I want to, just now we'll try to convert into simple loop. All right, so what will happen now? It will execute 5 times, right? I'm audible. 5 threads will be created, right? 5 threads will be created and 5 thread will execute the task, right? I'm audible.
Yeah.
And let's, if we can print the name of the thread as well, thread name, so that we'll know that which thread is executing the code. So greeting thread dot name, right? So anyone can want to speculate what will be the answer output. Thread 0, thread 1, thread 2, thread 3, thread 4, right? From 0 to 4, 5 threads has been created, right?
Yes.
And I need to call the start as well. What if I only want a single thread to execute everything? I don't want 5 thread, I only want 1 thread. So in that particular case, what I can use now, you cannot use it executors, I can use executors. Cool. Yes. So executor is, you can see it was introduced in 1.5, one of the most powerful versions of Java that has changed the multi-threading. So what I can just directly ask for is new single thread executor. Cool. Now I want executor service object. Executor object provide executor service object, right? Then executor service equals to executor service. Now what I'm going to do is for int I equals to 0, I less than 5 and I plus plus. What I'm going to do, I will provide submit, right? First thing, I don't need to create a thread, right? Let me just comment this section out. All right, even remove the section entirely. Cool. So my runnable, I'm directly providing, because this is a task, right? Greet happy new year task. This is a task, right? We call runnable task. I hope everyone is remember this thing. So I can directly put the executor service and then print and send it to the executor service to execute, right? Now if I try to run one thing, there is no need of a thread class, right now. And happy new year is printed 5 times, but we need to know how many threads were used, right? Over here it's mentioned the new single thread executor. That means a single thread will be created. So if I try to submit a task to this executor service, then it's going to use only single thread, because this method creates executor with a single worker who represents a thread. All right, now the next thing that we need to know, which thread is executing this, right? We need to know whether there are multiple threads involved or not. If Java has written, okay, there is a single worker, right? Why we believe you? So what we can do, okay, no one needs to believe me or anyone else. We can simply write a little more code. We will simply write a little more code, and okay, we don't even have to write this thing, right? We can simply print over here that thread. All right, let's write in the front thread dot current thread and get name, right? My bad. So now the task is to print the name of the thread that's executing the line, and then hello user, happy new year, right? So if we run this now, what should happen? Okay, expected where? Oh, my bad. All right, let's okay, this curly braces also. All right, we don't even require those things. Cool. So now if we run this, what should happen? All the thread names will be same, right? Pool thread 1, right? Pool thread 1, right? Pool 1 and thread 1 visible. So same thread is executing this thing, visible.
Yeah.
Now you can say that, all right, why we believe that this pool 1 and thread 1 is the same thread. So all right, don't believe me, no worries, we can write different thread as well. So we will write a new example, executor fixed thread pool, cool, or dan runner. So what we are going to do, we are going to copy paste the entire same code. All right, so if I run this, the same output you will see, right? Hello pool user 1. So what I'm going to change over here is, instead of taking a executor with only a single thread, right, I will take fixed thread pool, right, and I will put 2. Over here is n threads, right? I'm saying that okay, 2 workers are the 2 threads you can use. So now the output, instead of pool 1 thread 1, there should be pool 1 thread 2 also, right? Because there are 2 threads involved. Okay, right? I'm audible?
Yeah.
If I make it 1, then it will be equivalent to the new executor, single thread executor, right? So if I have written over 1 here and try to run this code now, you will see the same output will be there, right? Thread 1, thread 1, thread 1, thread 1. But if I make it 2, then what will happen? There is some task has been assigned to thread 1 and some task has been assigned to thread 2. All right.
Okay.
If I make it 3, now there might be a chance some thread be assigned to 1 and 2 and then 3, and there might also be a chance that only 1 and 2 will be able to execute those tasks directly. All right, so 3 is also involved. See, 1 2 3, 1 2 2 and 3, all threads were involved. Cool. So now the question is, first, what is the difference between single thread executor and what is the difference between n threads executor or new fixed thread pool? Okay, n thread is here, right? Over here if you go, so this is n thread, so n thread executor service. So over here, what's the difference between these two? And the very first thing, what is executor service here?
Executor service is used to run the same task with different threads.
Okay, it's cool. Okay, it's one of the workflows. But the thing, if you'll try to see one thing, that it's in the package of concurrent, right? You'll see concurrent is a great package. I mean, great as in, because you'll see atomic locks, right? We have already talked about the locks. So it has everything that we require. Okay, function. Okay, all right, cool. Function should not be there because I have collapsed the concurrent package, right? These are the things in the concurrent package. Blocking queue we will see in a while. So see, concurrent map. Okay, we'll see that in the later part. The concurrent map also a part of concurrency, right? It's the one of the most important question, right? Concurrent hash map. And then barrier, you will see it here. Latches, you will see it here. Everything you will see it here. Executor, executors, executor completion service, fork join task, fork join pool. Not going to cover this thing, but it's important as well. And fork join worker thread, we'll see these things also in when we cover the priority blocking queue, right? Why we use this, why priority blocking queue we require, but why priority. See over here, you will see the blocking queue as well. All right, so when to use blocking queue, when to use non-blocking queue, not going to cover in the course, but it's important as well. It's a part of data structure, right? Schedule future also not going to cover, but you will able to, I mean, it's very easy, right? Semaphore is important, not in the course, but still it's good thing to know how it internally works, right? All right, okay, let's go out. I mean, the concurrent package is good package. I mean, most of the things that we do in the while creating the highly scalable environment, and that too in the single microservice, because scaling is a different thing, but in the single microservice we want to make the concurrent system. Then all those things is important and we use it in the daily life, and some of those things are happening internally, because the queues and the blocking queues, see over here it's using, right, internally it's using blocking queue, link to blocking queue, visible?
Yes.
So internally these are used. I mean, if you don't know it, there is no worries, but if you know, then it's good. So all right, let's move to thing executor service, right? Why we need executor service, and why the
Yeah,
people.
Abhishek,
Yeah.
Abhishek, once, how did you, that definitions, how it came on that left side sidebar is to cut?
Come again, left side sidebar, I don't know.
I mean, you clicked on concurrent and all that libraries showed up in that left sidebar, right?
Okay, that's a part of the ID. If you just click on here, then you will go to that package, and from the package you can list all those things, right? And the thing is, don't go inside those things. I've just shown you that it's not, if you don't know the concurrent package, then it's not like it's the end of the world. Most of the time you will never going to hurt those things. That's why it's not in the course as well, right?
Okay.
So these are the things you can, it's in the jar, you can go inside and check all those things. But the thing is, it's not like there are n number of exceptions, right? There are n number of things that exist in the multi-threading. Not everything is required to be known. The thing is, if you're
Okay.
using thread pool, see, when, if like you suppose you join a firm which don't use multi-threading, so why do you need to know about these things, right? If your entire life you are now going to
Okay.
use this thing, multi-threading, or let's say that you moved from Java to some other language, let's suppose you move from backend to front end, then this will be of no use, right? I don't think, okay, this will be of use because the concept will remain same, but not the executor service and why it's introduced, and those things will not matter, right? So we need to be very mindful what we are learning and what we are not learning. If it was way too important, I would have put in the course, but these things are important, and already Java, I mean, the multi-threading is way too extensive, so I'm not taking all those things. If you know the data structure, while the priority queues, what's the queue, what's the priority queue, linked priority queue, then it will be same, right? If you know the data structure, then it's completely fine. The same logic, I mean, you will be able to know that why it's there. All right, coming back to the point, executor service, right? So why people think that we, let's introduce the executor service. What's the benefit of the executor service, right? First thing, please everyone know, no one creates thread equals to new thread, right? No one creates a runnable object, right? I think I'm already clear that we use lambdas to create the thread in 2027, sorry, 2024 5, sorry. So nobody use thread, nobody extend the thread class, or nobody creates a new class by implementing or extending the thread class or implementing the runnable interface. No one do it, right? We either use this thing, or we use, I mean, we are going to create, I mean, we are not even going to create a thread object, right? Not by the lambda, not by the anonymous class. We are directly going to create a task, and we are going to submit it to the executor service, or we'll provide it to the completable future that we are going to see in the later sessions. All right, so the first thing is the same task, right? Okay, let's go here and compare. Okay, my bad. Okay, all right. Okay, so let's suppose I have to do this task, right? So how I'm going to do it in without executor service? So the same thing will be there, right? I have to start from 0. I will go to the 5. This is the normal looping, and then I need to create a thread object, right? Thread equals to new thread, and then I need to submit executor service, and then I need to start the thread, right? Okay, not the executor service, but a task. Cool. This is the way that we write, right? The similar code that we have written over here, right? Visible? 17 to 20 and 22 to 24. It works
Yeah.
right, but the thing is over here I'm creating a thread object, right? The thing is, if I have created a runnable, if I created a task, and runnable is something that needs to be executed in a parallel task, so why should I create a thread again and again? First thing. Second thing, I mean, this line, creating a thread and starting it, is redundant, right? To optimize it before Java 5 version, what I can do, I can directly call it the start method here, right? Right? I'm audible?
Yeah.
Yeah.
So I know that if I created a task, then I will execute it by creating a thread only, right? So why to create thread again and again? And what if I want to execute the same task again and again, like the case that we are having right now? I just want to print this thing again and again, that hello user, happy new year. I need to print it again and again. So they are forcing me to create another thread, right? I cannot reuse a thread, right? If I've created one thread over here, then it's dead. I cannot reuse a thread. But in the executor service, I can reuse the thread, right? Same two threads or same three threads are being reused, right? Two second thread used here and second thread used here, right? Visible? Third thread used here, third thread used here. But if I use this way, I cannot use the same thread again. I cannot submit another task to the same thread. This feature is not, or functionality is not there. So if I want only 4 threads to be created, but if I'm looping it around 1000 times, then I have no feature if I'm creating a thread object directly. That this thing is one of the biggest drawback or the looping. And also the second thing is, redundantly I am writing this thing, right? There is no need. If I've created the task, just tell me how many times it needs to execute, right? So the submit over here, if I am submitting it, then it's going to run it, right? Run the task, runnable task, right? Over here Java also use the same terminology, so that we don't call it runnable task, we call it task only. So when we submit a task, it will run, right? And return a future will see in a while, right? So, and some, I mean, executor service work with the callables, and callables futures we'll see in a while. That's also a part of it. But the thing is, executor service is a part of concurrent package, most important package in terms of multi-threading. And it's provide a high level of implementation, right? Because I'm not creating a thread, I'm not managing it, right? Why I'm saying managing? Because I'm creating it, right? One state, I'm making it runnable, right? Second state, right? So it's a life cycle part, right? We have seen the life cycle of a thread, right? Remember, new, runnable, waiting, sleeping, dead. Okay, all right, wait, we have covered the life cycle of a thread: running, waiting, sleeping, dead, new, ready. Visible?
Yeah.
So we are managing new thread and ready state, right? Two states of a thread we are managing. And even if I do some other stuff, that dot wait and those things, then also the other stuffs also I'm taking care by using the thread object only. And thread dot join, right? Join is also there. So the thing is, if I use the executor service, I don't have to deal with it. So it provides a higher level replacement for managing the thread and creating the thread object, right? Creation of the thread, managing the thread lifecycle will be handled by executor service. All right, I'm audible?
Yeah.
All right. So executor service abstracts the process of creation of thread, management, and the life cycle, and then it makes easy, right? It makes way too easy to work with the threads. And one don't even need to know that a thread equals to new thread exists in today's era. If one skips that thing, that also it's completely fine. But the thing is, if I don't teach that thing and someone asks this thing, then there might be an issue, because that question is way too famous. Which way of creation of thread is important, right? With runnable, with implementing runnable or extending the thread class. So that question is very important, and some people still ask this question. I don't know why. Cool, but that's the thing, right? Good with the executors now? Hello, I'm audible?
Yeah, Abhishek, yeah.
All right, see, but that's not the only thing. All right, so see the thing. Okay, I'm not going to cover a lot of stuff. So over here you can see, if you just click, try to see the executors, a new fixed thread pool we have seen, right, already. Then new single thread executor we already seen, right? Now there is this new cache thread pool, right? And then new cache thread pool will use thread pool executor internally, right? But what's the difference between these two? This thing, okay, so when I use this thing, right, new single, okay, see, this will create only a single thread, right? But if I'll you okay, let's go to there only. Okay, all right. So this thing will create 3 threads, right? Directly it's going to create 3 threads, right? As soon as line number 11 executes, it will have, the executor service will have 3 threads. That's the internal implementation of it. But if I change it to cached thread pool, now what will happen? Okay, it's also require the thread factory, but what will happen with this is it will not create all the threads at the runtime. It will, as soon as we need, like for example, if I have a single task and I don't need the second thread to get created, then it's not going to create the second thread. The threads will be created as needed and reused as frequently as possible. Let's suppose I have mentioned that okay, 3 threads you can use, right? But if there is a task that requires only 1 thread, then it's not going to create the 3 threads. And that's the one thing of it. I'm audible? Hello? I'm audible? I'm audible?
Yeah, yeah, yes, yes.
All right. So next thing is that we are going to see is callables, right? So, and there are different, I mean, executors service can create a pool of different ways, right? One thread and thread, different ways is there, right? Schedule executors are also there if you want to do some tasks periodically. Okay, those things are the cherry on the cake, right? We need to know about the cake. These are the concepts of the cake. Now we'll start the callable. All right, so the first thing, can we use callable with the thread equals to new thread? The answer is okay. See, no callable here, right? So we cannot use callable with this thing, right? What's the drawback of the runnable? See, in this course we will see 3 things, right? Runnable, callable, and supplier. Cool. Runnable we have seen, right? I'm audible?
Yeah, Abhishek.
So what's the drawback of runnable? Okay, this is also a question that we'll cover later on, but all right, cool. See, what is a runnable? Runnable is an interface, right? And is it some special kind of interface? Yes, it's a function interface, right? So function interface is only one abstract method, right? We don't care how many concrete method exist in the function interface, but function interface states that there should be only and only one abstract method, right? So this is with the runnable. Now the thing is, the drawback of the runnable is that we cannot use runnable to return the values, right? The return type is void. Visible? Hello?
Yeah,
Right? We cannot return the value. So I want, there are multiple, one more drawback, or it depends in which way we are trying to say it, but we'll cover it later on. First thing is, we'll see that callable we want to use if we want the data to be returned, then what we are going to use? Callable, right? So let's see. So callable, it's callable also, okay, let's Okay, inside executor, let's create the callable. And the reason I'm writing this thing inside it, callable package, is callable was also introduced with the Java 5 version, right? Callable, okay, let's write basics. Basics. So callable basic callable runner. All right, so the thing is, let's suppose you are you are a company of who sells the package. Okay, cool. The current company that I'm working for, right? Let's suppose in the package you have the flight, and then you have the hotel. Cool. So now the thing is, you want to call two people, right? You want to call the flight team and get flight price, and you want to call the hotel team and call the hotel price, right? And then there can be activities, right? Activities like paragliding, skydiving, or anything like Burj Khalifa you want to visit, museum if you want to go museum of the future, those things. I'm in this team right now. Cool. So you want the price of activity, get activity price, the ferry, all those things comes in the activity. So you want to get the price of these three, and then you will give the total price to the user, right? Total package price, right? This is how the thing should be, right? X plus y plus z. Am I audible? Hello.
Yeah.
All right, now let's suppose there are three APIs, right? Public, okay, static we have to make sure, and get price, and get okay, get flight price, okay, my bad. Get flight price, and what it's going to do, it's going to wait for thread.sleep for 4 seconds. I'm trying to mimic the API call, right? And then it's going to return 100. All right, so sneaky throws and int. Cool. And then public static int get hotel price. All right, let's take 2 for the easiness. Let's take all 3. I'm in the third team. So thread.sleep, and let's say it takes 6 seconds, right? And it will return 50 hotels. Okay, if you stay longer, hotel will be costlier, so 200. And all right, and then sneaky throws, and then there will be price of activity. So public static int. So because okay, so activity can be costly, can be less, but I'm in this team, so it should be costly. Okay, and it should be fast, right? It should follow the basic principle of 30 milliseconds. All right, so sneaky throws. Cool. So now the total price should be 200, 400, 300, 700, right? I'm audible?
Yeah.
And the total time it's going to take is 4 seconds, 6 seconds, and 30 milliseconds, right? So almost 10 seconds. So what if, so flight price equals to get flight price int hotel price equals to get hotel price, and int then activity price equals to get activity price, right? And then if I try to print total package price, okay, my bad, then it will be flight price plus hotel price and then plus activity price, right? But the thing is, how much time it's going to take. Okay, my bad. So let's start int or system dot current milliseconds, and it's going to give me long start time. All right, and similar thing I'm going to do with this, and over here it will be end time. And then the next thing, long total time taken should be the end time minus the start time, and this time needs to be divided by 1000. All right, let me check it once again. I've 10 more. Okay, milliseconds, right? It's cool. So total time taken. All right, so total price is this, and over here total time taken is this, right? Cool, visible. So let's run this. What will happen? The total price it will provide, and it will display the total time taken as well, right? In seconds. Okay, my bad. In seconds, right? Visible. I'm trying to mimic the API calls, right? And then the metrics. It's not usually in the production environment. Nobody is going to do this thing. This is for the local. We have the matrices to measure it in the runtime. So if I try to run this, what will happen? It's going to run, and then it's going to wait and wait, and it's going to wait for 10 seconds. And all right, it's been a while. See how many seconds it has taken? 10, right? Total 700, right? And it makes sense because 4000 milliseconds is here, 4 seconds and 6 seconds, right? And then 30 seconds it has skipped this thing. Cool. Am I audible?
Yeah.
All right, so this data is correct, right? So if this thing I cannot use with the callable. This thing, if I try to run with the runnable, I will not be able to execute the code, right? Because runnable don't return anything. Am I right? So it's, let's say it's basic. Okay, let's take this an example of package calculator and move it to somewhere else. All right. Okay, my bad. I'm not like this. Package and package price calculator. The thing that you are seeing here is the thing that we are paid for, and I'll show you how we can optimize it later on. So this is the thing that we have in the basic callable runner, and instead of basic it will be basic package calculator runner. All right, now we are going to write optimized package price calculator. All right, so in this code we are going to copy the entire thing that we have written over here. Oh my bad, over here. But thing that we are going to do is, instead of calling it at a single time, okay, first thing is we will use the executor dot new not cached single not and pool. Let's take a thread of 3. All right, we need to call 3 times, right? So now executor service. All right, visible till now? I'm audible? Hello, I'm audible?
Yes, sir.
And then
Yeah.
instead of doing this and doing it separately, okay, all right, shit. Okay, but the thing is future also, okay, future also require, okay. All right, but if I don't use future then it won't make sense. All right, but can I do it without the future? Okay, we need to know about the future as well. All right, for completing this example we need the future. So instead of taking this thing, let's work with the basic one first. Let's work with the basic but if it will return the future itself. Okay, all right, cool. So okay, but callable object we can create. Okay, all right, so let's start with the basic and we'll come back here in a while. So okay, let's write the example first here, and then we can work later on. See, the thing is, okay, let's just see the example. We'll break it down after a while. All right, we are writing the example first. So we are calling this function, right? And we are waiting for the price as the output, right? I'm audible? Hello?
Yes, sir. You're audible.
Okay, wait. We have to cover the future and callable separately, then only it will be better. Otherwise, it's going to take some time to understand. And basics, okay, already exists. I'm not trying to create package. I'm trying to work with, I'm trying to write a class. All right, and do, okay, new package. All right, basics. So all right, no worries. In basics, let's add callable and future. All right, so example, directly runner, callable runner. So see, the thing is, I want an integer as an output, right? So let's see the callable interface first. Callable is also an interface, right? And it will be a, because it's a alternative to the runnable, then it also requires to be a interface, and to be specific, the function interface, right? You can see it over here, and over here you can see it returns something, right? It's the v value. It's a generic part. We are not going to cover this in our course, but it's generic. That means you can return it whatever you want. So over here, so what does it mean? I'll let you know that this thing is the generic, right? So that means this v will be integer, so this callable that we have created will return the integer every time. This is called a generic. So this callable, right? Earlier we were creating a task, right? So it is a task also, right? Get and get price task, right? Get, let's say that it's a flight, get price, flight price task. All right, our flight price task, our runnable is unable to return anything, right? I'm audible? I'm audible?
Yeah.
See over here, in the same manner, if I'll try to write this thing now, okay, wait. All right, so what's the issue over here? Why it's, I mean, I can return the value, right? Why I'm unable to return the value? If I convert it to the callable, sorry, runnable, okay, if I'll convert this to runnable, and then if I don't return it, I'll just sys out, then it's fine, right? It's fine, right? Similarly, if I convert it into callable, what was the drawback earlier? I'm saying that it's going to return an integer. Let's call it task, and this is the task, so it will be same, right? Can I return 20 directly? Why it's giving error? If I cover this, then cause of this semicolon, it was showing an error. We can write it
Yeah.
in the same manner, but just cause of semicolon it was crying. So can we write twice? No. So the thing is, whenever we are writing the callable, we need, is it required for curly braces? Yes. So this one liner that we have written earlier, we require the curly braces with the callable. Cool? Understood?
Okay.
So now this thing is going to return the price, right? And we know that we cannot use callable with the thread. So the only example that we have right now is executor service, right? Let's create a single thread executor, and then executor service, and then executor service equals to new executor service. Then I will submit the task, right? Submit. Can I submit the runnable? Because we have submit the callable. We have seen to submit the callable. Can I submit the runnable? Yes, obviously. It is also okay. Callable was also introduced in Java 1.5, right? And it was, see, over here it's also showing that okay, if you are learning about the callable, please see the executor as well, right? Because it is used in conjunction with the executor, especially in 1.5. All right, let's move backward. Now if I have submitted this, right? Okay, let's try to write one more code. Before returning the value, let's suppose I want it to print hi calculating the price of flight, right? And if I run this, what will happen now? See, same thing, it will print this thing and return the value 20, right? Hi calculating the flight price, right? And if you want to know the name of the thread, it will be same that we have seen till now. It will be same. If I run this, pool1 thread 1, right? The similar thing that we have seen when we try to submit the runnables, visible? But all right, now we have seen that okay, it's giving us the value that we have running. That means a thread is running it, right? Because this line is executed by the main thread, but internally the thread pools1 and thread 1 is executing the line number 15. So till here everything clear and fine, but the thing is, for return 20 we haven't done anything with the value 20, right? Nowhere to be found 20.
Yeah.
Right? So the thing is, cause this thing might cause this value can take some time, right? Let's suppose if I'll put the thread.sleep and I put sleep for 10 seconds, then what will happen is over here the main thread will move, right? Let's print it. This line is executed by the main thread. Thread dot current thread dot get name and ends, right? If I run the code, main thread ends, right? And then this thread is still okay. 1 second, it's only 1 second. Let's make it 10 seconds, right? So I'm running it again. So the main thread's already ended, and then still this thread is running, right? Thread pool 0 thread 1 is still executing, and after 10 seconds it has printed this thing, right? So the thing is, if I expect the value like this thing, int flight flight price, if I'll try to write the code in this manner, then what will happen? And if I try to print the value here, this is out flight price, then what will happen? Cause the main thread, right? The main thread will come over here, right? In this line, while the thread is in waiting, which is responsible to pass the value, right? This 20. Is this thing clear? Because main thread is submitting the task to the executor service, and the main thread will move to executing the next line, right? Is this thing clear? The main thread will keep move to this line number 23, while this thread 0 and thread 1 will be waiting for 10 seconds. The main thread will try to execute line number 23, and where the price will not be present, right? I'm audible? Anyone, any doubts? Please let me know now. I'm audible? Hello?
Yes, sir. You're audible.
Okay, anyone, any doubts over here? See, treat it like callable is nothing different, it's just a runnable, right? It's just a task, alright? And it's executing over here. I am submitting the task, I am not doing thread.start, right? It will be done by executor service. So when I am providing the task is to wait for 10 seconds and then returning the value. But it will be the thread which will going to wait is the thread 1, right? But the main thread will, as soon as main thread submit the task to the executor service, it will move to the next line, right? Executing to the next line. This thing is clear, right?
Yeah.
But till that time, the flight price will not be there, right? Because this thread, which is responsible to return the flight price, is waiting for 10 seconds. So what value will be here, right? So that's why if executor returns you something, it don't return the direct value. It return you the future object. What does it mean? It means when you execute the object, okay, this flight price. All right. So this means that when you are going to execute this thing, execute the callable, then the callable is going to return some price, right? But it's going to return the price or return the output of the code inside the callable. But the value, there might be a chance you are not going to get as ASAP, right? Because it's going to take some time. Like this thing is going to take 10 seconds. So you are going to get the flight price in the future. Right now you don't have the price, you will get the price in the future. So that's why over here also you get flight price dot get. And now the thing is, flight price dot get, what it do, it makes you wait for getting the result, right? I mean, let's forget this thing, and it throws an exceptions also, so I'm putting the sneaky throws right now over here. So now what will happen, as soon as the code reaches here, it will see the get, and then it's going to wait until my flight price, this callable, returns the value. It's like equivalent to the join that we have seen.
Okay.
Now if I run this, okay, let's use the flight price also. Okay, flight.get will give the price, right? So let's run this now. Illegal character, oh my bad. All right, let's run this again. Now see, oh okay, my bad. Okay, okay, stop all three. Cool. So let me just write down hit the API of flight service. Cool, let's run it now. So I have hit the API of flight service, and the flight service team is way too lazy and their API is way too slow. So it's going to take 10 seconds, and as soon as 10 seconds over, then it's going to see calculating the price after 10 seconds, and the flight price is 20. Cool. And then the main ends. Visible?
Yeah.
So the thing is, we don't wait for the executor, for the callable to return the value. We just moved on by taking the future object. So the same thing that we have done with the flight. Now with the optimizer of the package, what I'm going to do, this thing, get this thing, I'm going to create the callable, right? I'm going to create a task. So what I'm going to do now is, I'm going to get the flight price. And how I'm going to get the flight price? By simply calling, okay, and okay, let's write down sysout finding the price of flight, okay, or simply hitting flight API for price. And let's write the thread name also that executing it. All right, so this thing, and how we are hitting the price, this, and just simply return this. Cool. And similar way, we are again going to write a callable, and same of integer, and it will be hotel price. Okay, let's change the name. Get, oh my bad, no, my bad, get flight price task. Cool. Get hotel price task. and over here also, my bad, same thing we are going to do. And simple copy paste and hitting hotel API for price and get hotel price. Simple copy paste will do, get activity price and activity, right? So get activity price. And now the thing is I need executor to run. Okay, already have the executor, great. So now I have the executor. I will submit the get flight price task, and over here future will be there, future and integer. I will get the value in the future of the price and flight price, and that's it. And testish, and over here hotel price, and okay, let's change it to flight price task, and we change it to get activity price task. Why it's not a task? Okay, task, and then just copy and paste, and over here instead of flight it will be activity price, and eventually instead of calling it one by one, okay, correct, the total time taken should be, now the value, now this thing should move above, and this thing, okay, total time in second. Okay, instead of this, now first I'm going to create the int total price, total package price, and this thing will be flight price dot get plus hotel price dot get, and then the activity price dot get. And all right, over here, okay, and now what I'm going to do is simple current end time, start time, where is start time is there, and okay, total time taken in seconds, and we should provide the total package also, total package price, total package price. All right, is it clear? Example, am I audible? Hello. We have three callables for flight price, hotel price task, flight price task, and the activity price task. Now we don't have to create the thread equals to new thread. We don't have to do it because entire thread creation to this lifecycle to the management will be taken care by the executor service. In the executor service, we have mentioned that okay, please create 3 threads, and over here we have mentioned the threads also, right? And in the task that we have mentioned that okay, these many seconds it's going to take. All right, let's all right, okay, hitting API we have already written in that thing, then we don't have to write it here. Cool. All right, let's run it, right? Anyone having any doubts till now?
Yeah, clear.
All right, cool, let's run this. So see, earlier how much time it required? 7 seconds, right? Okay, let me check it. 6 and 4, 10 seconds it has taken in the last time, right? I'm audible?
Yeah.
And this time it has taken only 6 seconds. Let me run the basic one again to just make sure you understand this thing. If I run this now, it's going to take complete 10 seconds. It's obvious also because 4 seconds, 6 seconds, and 30 milliseconds, right? 10 seconds, right? Price is 700, 10 seconds. It's going to take 10 seconds only because we are linearly executing these things, right? First 4, then 6, and then 30 milliseconds. So it's always going to give you 700 milliseconds. But if you run the optimized version of it, it always gives you the maximum one, the maximum time it's going to take, right? 6, 4 and 30 milliseconds. Maximum time is 6. So it can sometimes give more than 6 seconds. And oh, why? Okay, I have executed the second iteration. Okay, cool. Okay, this is optimized one, right? Let me run it from here. It should not give the 10 milliseconds. It should always give less than 10 milliseconds. See, again 6 seconds, right? And this is why you get paid better than the rest of the world, because you can optimize things, because times matter everywhere. And we can even optimize this code, right? These callables will be inside a method only. Every callable will be inside a method, so that this code will be little beautiful. And there will be a method, right? Instead of task, these all will be a method, like get flight price task. Simple, this thing. Okay, cool. And I don't need this thing, then I will directly put this get flight this task over here. This is the way in which we write production code in environment. And over here also get integer callable. No, get price hotel price task. So this thing again cut and paste, and over here, and this also get activity price task. So this thing we are going to get, and we can put it here, right? And in production environment you will never, okay, let's move this comments above. And in production environment you will never see this start and long, right? We have matrices annotations, and that's it. Now see this line, right? So if you will be in production environment, we won't be having this, we won't be having this, we will have this much only, this values only, and not this as well. And we are going to just return this, and we don't usually write code in this manner. If it returns it just as a void, right? So we cannot return anything, so eventually we will return this. So this is how we write code in the production environment. So if someone is reading our method, he will read only these 5 lines, right? And a method should only have 3 to 5 lines, not maximum than that if it's possible. And in most of the cases I have seen that we can write code in 3 to 5 lines only, like this thing that we have written. So now if you try to read the code, you will see, okay, we are getting the flight price, we are getting the hotel price, we are getting the activity price, and we are adding those things, and then we are returning it directly. That's it. Readable also, right?
Yeah, Abhishek.
This is how we write code in the production environment. But right now we are here to learn the thing, so we'll replace things back in the original state. Okay, let me just put it back, everything. Now, all right, let me just run it once just to make sure it's working properly. All right, it's working properly. Now it's fine. After 6 seconds